Hi, welcome back to ChemTube channel. I'm Jaku Wong. Today we are going to look at the Melaka Trial Chemistry Paper 2. Let's start. As usual, we look at the essay part, question 7. Diagram 7.1 shows the pH value and concentration of hydrochloric acid and ethanoic acid with the same concentration. So you can see here for the hydrochloric acid, the pH value is 1.0. And then for the ethanoic acid, the pH value is 4.0. They have the same concentration. The question sounds, explain why the pH value of two acids are different. So there are 4 marks here. So how do we answer this question? So we have to know the knowledge of the weak acid. So what is the meaning of weak acid? It is a substance that ionizes partially in water, forms concentration ions in the water. So the degree of ionization is less than 100%. For example, is the ethanoic acid. So only part of the molecules are ionized. So if the concentration of hydrogen ions decrease, means pH is higher. For the strong acid, is a substance that ionizes completely to form the hydrogen ions in the water. So you see the hydrogen ions ionize completely into the hydrogen ions and then the chloride ions. For example, the chloride. Hydrochloric acid. So there are 4 marks here. So what should we write? Point number 1, we can mention hydrochloric acid is a strong acid. It ionizes completely in water to produce high concentration of hydrogen ions. Then last point, the higher the concentration of hydrogen ions, the lower the pH value. So this is how we can get the 4 points in this question. You may answer, you may explain for the ethanoic acid as well. So for example, you can mention ethanoic acid is a weak acid. It ionizes partially in water, produce low concentration of hydrogen ions. So the lower the concentration of hydrogen ions, the lower the pH value. So this is also accepted if you explain for the ethanoic acid. Okay, next B. A student carried out an experiment between the excess hydrochloric acid and 2.5 grams of calcium carbonate. Write the chemical equation for the reaction and calculate the volume of gas released at the standard temperature and pressure. So you are given this question. You are given the relative atomic mass and then molar volume at STP, 22.4 cubic decimeter per mole. So before we start to answer this question, so let's see this video. So you can see the gas produced will release will turn the lime water to cloudy. Okay. So the first point we can write here is the equation. So chemical equation. So 2 marks. So 2 hydrochloric acid react with the calcium carbonate to produce a calcium chloride, carbon dioxide and water. So the carbon dioxide will be released and then it turns the lime water to cloudy. Okay. So you are given that the hydrochloric acid is excess. It is the excess. So meaning that we have to see the limited reagent, that is the calcium carbonate. Okay, So given to you the calcium carbonate, the mass is 2.5 gram. So we can calculate the number of mole by using the formula mass over the molar mass of the calcium carbonate. So calcium carbonate, we replace in the AR, calcium is 40, carbon is 12, and then oxygen is 16. There are 3 of the oxygen atoms, so times 3. So you can use your calculator, and then you will get the mole is 0.025 mole. Okay. So after that, the question asks you to calculate the volume of gas. So you get the number of mole. So for the calcium carbonate, then you are asked to find the volume of the gas here, carbon dioxide. So we have to do the mole ratio. So 1 mole of calcium carbonate produce 1 mole of carbon dioxide gas. Then 0.025 mole of calcium carbonate also produce 0.025 mole of carbon dioxide gas. Okay, so finally we can find the volume. Volume equals to mole times the, so this is not the hydrogen, is carbon dioxide. Okay, so number of mole times the molar volume. So 0.025 times the molar volume 22.4, you'll get 0.56 cubic decimeter. Oh, okay, so this is how we do the calculation. Oh, so there are 3 steps. Step 1, you need to calculate the number of moles. Number 2, you need to calculate the mole ratio. Then finally, you have to count the volume of the carbon dioxide gas released. Okay, so next question. You can see, okay, table shows the apparatus and observation of 2 sets of experiments. The aim of the experiment is to study 1 physical properties and 1 chemical properties of the acid when glacial ethanoic acid is dissolved in solvent K and L. Okay, so here, okay, you can see you are given glacial ethanoic acid in solvent K and solvent L. So you can observe, okay, in the solvent K, the bulb lights up, okay, lights up. But in the solvent L, okay, the bulb does not light up. Okay, so there is a difference. Okay, so here I provide a simple video for you to refer.
The ethanoic acid molecule ionizes to form a hydrogen ion and an ethanoic ion.
Okay, so meaning that if you look at here, if it ionizes in water, it will produce the ethanoic and the hydrogen ions. But in the water, so the only solvent that can make the acid to ionize is the water. Is the water. So meaning that here we know that the solvent K, it should be water. Okay. Without water, it cannot show any the bulbs does not light up because the ethanoic acid is still in the molecule form. Okay, so another words here is the glacial. Glacial means dry or pure, meaning the meanings that the ethanoic acid still in the molecule form. Okay, so this is for set 1. For set 2, okay, you can see here also the same. Okay, so glacial ethanoic acid in the solvent K and solvent L. So if put in the calcium carbonate, the marble chips, so here you can see the colorless gas release. Then lime water turns to cloudy if you test the gas with the lime water. Okay, then here will be no change. In other words, here also the same. This one should be the water. With water, then only the ethanoic acid can ionize to form the ethanoic and the hydrogen ions. Okay, for this one in the solvent L, it still exists in the molecule form. Okay, so based on the table 7 here, suggests solvent K and solvent L. So here just now I mentioned already, solvent K, it should be water, water. Then solvent L, you can put any suitable organic solvent. So I suggest to you here is the metabenzene, or you can give any suitable organic solvent. I can let you know. Okay. Next, explain the difference in the observation for both sets of the experiment. So write one chemical equation involved. So here, I suggest you to use the table form to write your answer. Okay, so 10 marks. So here, okay, in set 1 first. Okay, set 1, what is the difference? Okay, so you can mention, okay, in solvent K, okay, it can conduct electricity. It can conduct electricity. This one cannot conduct electricity in solvent L. Because you can see the bulbs light out in K, but L does not light up. Okay. Next, why? Because ethanoic acid ionizes in water, but it cannot ionize in solvent L. Or in solvent L, you can mention just now is metabenzene. Okay, then because it ionizes in water, so it has freely moving ions in solvent K. Okay, but in solvent L, it still exists as molecule and then no freely moving ions. So this is how you can present your answer for set 1. Okay, so for set 2, almost the same. You can also present your answer like this form. Okay, so set 2 just now, okay, this one produces a colorless bubble gas and it turns the lime water to cloudy. Okay, then for this one also, no change in solvent L. So what can you write? So carbon dioxide is produced in solvent K. This one, no carbon dioxide gas is produced or no reaction occur. Okay, same, because hydrogen ions is present. This one, no hydrogen ions is present. Then it can show the acidic properties. Okay, this one does not show the acidic properties. Or you can mention can react with the calcium carbonate to produce carbon dioxide. Okay. So if you have any question, you can write your comments or your question under the comments column below the video. Okay, next we look into, we need to write the chemical equation. So the ethanoic acid CH3COOH react with the calcium carbonate, produce the calcium ethanoate, carbon dioxide and water. Yeah. Okay, so this one we have to balance the equation. Okay, for your information, you also can write your calcium ethanoate like this, CH3COO bracket 2Ca. You can also write like this, also accepted. Okay. Now we move to question number 8. And diagram 8.1 shows a self-heating bag to heat the food for outdoor activities like camping or mountain hiking. The pack is filled with the granules of quicklime, calcium oxide, and packed together with a pack of water. So now I show you actually when the quicklime, calcium oxide, you put into the water, okay, what will happen? You can see. So it will react quickly. So if you stir it, okay, so it will produce a lot of heat. can see it's a lot of heat will be produced. Oh. Okay, so now we look into the question. To start heating, the water supply is poured into the quicklime packet. State what type of reaction it is. Okay, they explain the reaction that happened. So 4 marks. So before that, I would like to show you actually lime water, when it is heated, it forms a quicklime, the calcium oxide. Then calcium oxide, when it add into the water, it will produce a slag lime, calcium hydroxide. Then when the calcium hydroxide is carbonated, it will change back to calcium oxide. Okay, this one is for your extra information. Okay, so point number 1, it is the exothermic reaction, so obviously. Number 2, the quicklime or calcium oxide is dissolved in water, and then the heat energy is released, then used to heat the food. Okay, so very simple. 4 marks for 4 points here. So number 2, when the alcohol is burned, the heat of combustion can be calculated by measuring the temperature change. Calculate the heat of combustion of propane 10 if 3.12 grams of alcohol is burned in excess oxygen to heat 500 cubic centimeters of water until the temperature is changed by 50 degrees Celsius. Write a chemical equation for the combustion of propanol. Okay, so 6 marks. Okay, so before that, I show you the heat of combustion, how we do it.
The burner containing ethanol is weighed on the digital electronic balance. Record its mass in the table provided. A copper can filled with 200 cubic centimeters of water is placed on the clay pipe triangle. A thermometer is then placed in the water. Record the initial temperature of the water and the mass of water in the table. The burner is placed below the copper can and then lighted to heat the water efficiently. The water is stirred until its temperature increased by about 50 degrees Celsius. Record the final temperature of the water in the table. What is the difference in temperature during the reaction? Key in your answer in the table. The burner is weighed again on the digital electronic balance. Record its mass in the table. How much ethanol has been burnt during the reaction? Key in your answer in the table. Now, with the data we have, we can calculate the heat released from the combustion.
Okay, so this is how we do the do the experiment for heat of combustion. Here you are not asked to describe the experiment. So I just show you how it is done in the lab. Okay, now we need to calculate the heat of combustion. So first we have to calculate the heat energy release. We use the MC theta, this formula. So M is the volume of the water. So given you is 500 cubic centimeter. Okay. So 500 times C is the heat capacity is 4.2. Then the temperature increase it is 50. So we use our calculator. We get 105,000. Okay, 105,000 joule, or change to kilojoule will be divided by 1,000. You get 105 kilojoule. Okay, after we get the heat energy release, we need to calculate the number of mole. So number of mole of the propanol here, we use the mass over molar mass. So mass given to you is 3.12. Molar mass for the propanol, so propanol is C3H7 or H. So we replace in the AR to it, so we will get total is 60. So you get 0.052 mole. And finally, we calculate the heat of combustion, delta H. So Q the heat energy released over the number of mole. So you get 2019.23 kilojoule per mole. Oh, yeah. So this is delta H. And the equation for the combustion equation, so is the propanol, so C3H7 or H, react with oxygen. So during the combustion, you produce two types of products only. There is the carbon dioxide and water. So we need to balance the equation. Start with the carbon first. We have 3 carbons, so 1 carbon here, so times 3. Oh, then find the second one. We look into the hydrogen. So hydrogen is 8, so times 4. Then finally we look into the oxygen. 3 times 2, 6. 6 plus 2 is 6 plus 4 is 10. So we need to get 10 oxygen here. But here got 1 oxygen already. So we use 9/2. 9/2. So you also can times 2 to get rid of the 2 here. Diagram 8.2 shows 3 sets of experiments to conduct on 50 cubic centimeter of 0.1 mole per cubic decimeter copper 2 sulfate solution. The metal powders are all added in excess. Okay, so set 1, magnesium put into the copper 2 sulfate solution. So initial temperature is 28, highest temperature reached is T1 degrees Celsius. Okay, so here this one is magnesium with copper 2 sulfate. So actually I provide you the electrochemical series here. So magnesium is here, then copper is here. So tips for you here, you can see if the distance between the two metals in the ECS is further, okay, the temperature or the heat of displacement later on will be higher. Will be higher. Okay, in other words, the temperature change will be higher. Okay, next, for the magnesium, put into copper 2 sulfate. But this one, let me check again. Okay, this one is magnesium put into copper 2 sulfate. Okay, this one is 0.1 mole per cubic decimeter. But this one is 0.2. Okay, mole per cubic decimeter means higher concentration. Okay, then for the set 3 is the iron powder. Iron is here. Okay, iron is here, Fe. And then the copper is here. Okay, so this one, the distance will be closer. Okay, so it will be T3. Okay, so you have the idea already. Now we look into the question. Okay, calculate the value of T1 if the heat of displacement for the set 1 is negative 250 kilojoule per mole. Compare and explain the difference in the highest temperature reached for set 1 and set 2, set 1 and set 3. Okay, then state the color change for the solution for each experiment if there is any. Okay, now first we need to calculate the T1 first. T1 here. Okay, so given to you the heat of displacement, meaning that this is the delta H, given to you is 250 kilojoule per mole. Okay, so here we know that heat energy Q equals to mc theta. So m is the volume for the copper 2 sulfate is 50. 4.2 is the heat capacity. Then T1 we need to find out lah. Okay, next delta H given to you is 250. Next, mole given to mole you need to find is mv over 1000 because the metal magnesium given is excess in the question. So we use the mv over 1000. M concentration is 0.1, V is 50 over, this is not 60, over 1000, over 1000, get 0.005 more, 0.005 more. Okay, then next is the delta H is the Q over the mole. So Q equals to mole times the delta H. So mole is 0.005 times the delta H is 250. Okay, so you can use your calculator. 0.005 times 250. Okay, so it's 1.25 kilojoule. So you have to change to joule. Change to joule. So times 1000. So meaning that it's 1250 joule. Okay, then you can replace in here, into this Q. Okay, so meaning that our Q here, is 1250 equals to 50 times 4.2 times T1. So if I want to find the T1, so meaning that it needs to divide by 50 divide by 4.2. Okay, so you will get, so meaning that 1520 divide by 50 times 4.2. So you get 5.95 degrees Celsius, or you can round to 6 degrees Celsius. Both are accepted. Okay, so you get the T1 already. Okay, next you need to do the comparison Z1 and Z2, Z1 and Z3. Okay, let's continue. So if we want to compare Z1 and Z2, Z1, let's see. Z1, the difference here is the concentration 0.1 mole per cubic decimeter. Z2 is 0.2 per cubic decimeter. So meaning that, so T2 will be 40 degrees Celsius, for example. So the change of the temperature is double. Double means it will be 12. It will be 12. Because the Z1 just now, the T1 is 6 degrees Celsius. So T2 will be 12 degrees Celsius. So if 12 degrees Celsius, meaning the initial 28 plus 12, so it will be 40. Okay, so why? Because the concentration of carbon 2 sulfate or carbon 2 ions is double in the Z2 compared to Z1. So more heat energy is released in Z2 compared to Z1. Okay, any question you can write in the, you can ask below. Okay, next, Z1 and Z3. So T3 is less than T1. Why? Because the metal powder used is iron. Why? Because the iron is less electropositive than magnesium. So less heat energy is released in the Z3 compared to Z1. So observation, you can write in any one observation. So you can mention blue solution turns to colorless in Z1 and Z2, or you can mention blue solution turns to green in Z3. Why it turns to green? Because it changed to iron 2 positive is present in the solution after the reaction. Now we move to question number 9. So electrochemical series can be constructed by using the potential difference obtained when two different metals are used as the electrodes as shown in the diagrams. So two different metal electrodes put into an electrolyte. Here, electrolyte given to you is sodium chloride solution of 0.001 mole per cubic decimeter. So table 9 shows the result of an experiment conducted by a group of students using the apparatus set up in diagram 9. Now we look into the result here. So there are 3 sets using the different pairs of metals, but one of the metal is fixed, Y. Okay, and then different potential difference is produced, and then the positive terminal, okay, for each set of experiment. So using the result in table 9, arrange the metals based on the ascending order of the electropositivity. Explain your answer, 4 marks. Okay, so here, before we go to look the answer here, okay, so there are a few things you need to know. Okay, number 1 is the more electropositive metals means higher in the electrochemical series, it becomes negative terminal. Okay. Number 2, the further the distance between the metals in the electrochemical series, the higher the potential difference. Okay. So here you see, if the metal is located higher in the ECS, it becomes a negative terminal. So in other words, if this one becomes a positive terminal, means it is lower in the electrochemical series. Okay, lower in ECS. Okay, then this one, potential difference, meaning that 1.9 meaning that the distance is very far. 1.1 is closer a bit. This one is closer. Okay. Okay, so from the 2 information given here, okay, actually we can arrange first. So here we look into the set 1, magnesium and Y. So potential is potential difference is 1.9 volt. The positive terminal is Y. In other words, the magnesium is a negative terminal, Y is positive terminal, meaning that magnesium is higher than Y in the electrochemical series. So if we draw a line like this, okay, so we can put in magnesium is higher, then Y is lower. Okay, so the distance, so here is 1.9. Okay, we can write down here 1.9 volt. Okay, now we look into the set 2, copper and Y. Okay, now copper becomes positive. In other words, the Y becomes a negative, means higher. So meaning that Y is lower compared to Y in the electrochemical series. Okay, boleh? Okay, next, meaning that this one is 1.1 volt. Okay, then finally PB, lead with Y. Lead is positive. So in other words, you can see lead is somewhere here, because here is closer. So here will be 0.7 volts. Okay, so once you can arrange like this, definitely you can arrange them in the ascending order. In the ascending order meaning that from the lower to higher. Okay, so here from lower to higher, so it will be copper, lead, then Y, then magnesium. Okay, so you have to arrange it. So in set 1, Y is less electropositive than magnesium. Okay, then set 2 and set 3, Y is more electropositive than lead and copper. Okay, and finally the potential difference in set 2 or a pair of copper and Y is higher than the set 3, correct? So the position of copper is below the lead. Yeah, so this is how we arrange the metals in the electrochemical series. Okay, so any problem you still can ask the question at the video below the video here. Okay, next B. Diagram shows the observation for another experiment conducted by the same group of students to identify the position of metal R and S in the electrochemical series. So S, R and S. Okay, set A. So you put the metal R into the copper 2 sulfate solution. So it forms a brown solution, a brown solid. Okay, this one becomes thinner. Okay, so here is for set A, then set B. Okay, you put the metal S into the carbon 2 sulfate solution. There will be remains after a few minutes. No reaction, still remains. Okay, so predict the position of R and S in the electrochemical series. Compare and explain the difference of observation obtained in set 1 and set A and B. Okay, so here you have to know that carbon 2 sulfate solution here is here. Okay, so for A and B, so A carbon 2 sulfate solution, if metal A it can react, meaning that the metals must be higher than copper in the electrochemical series. So you can choose any metals above the copper in the ECS here, but except sodium and potassium, except these two. Okay, so you can choose any one of these. Normally I would suggest the student to choose the magnesium, zinc. It's very common. Okay. Then this one B, you see, no reaction. In other words, you can choose the one below the copper, not able to displace it. So the only choice will be silver here. Okay. So once you have the idea here, so you can answer the question easily. Okay, so brown solid form in the set 1 because R is more electropositive than copper. So no change in set 2, or blue solution remains in set 2 because S is less electropositive than copper. So S is lower than copper in the electrochemical series. So suggested here, R is magnesium or zinc, or any suitable metals except the sodium and potassium. Okay, these two cannot. Okay, hydrogen also cannot. Hydrogen. So you can choose any metals here. But normally, I suggest you magnesium and zinc. Okay, then S, no choice, only one, silver. Yeah. Okay, C. Puan Rohani bought a dozen iron spoons from the supermarket. He found that some of the spoon has rusted already. Based on your knowledge of electroplating, describe an experiment for that you can carry out the laboratory to electroplate the iron spoon. Your description must include the name of the electroplating metal, materials, apparatus, procedure, observation, and then the half equation. So 10 marks. 10 marks. So before we go to the suggested answer, I show you the video to produce the electroplating.
The process of electroplating copper coin with silver. Before carrying out the electroplating process, the copper coin must be cleaned with sandpaper. Then, the copper coin and the silver strip are attached to the setup. The silver strip is the anode and the copper coin is the cathode. The silver strip and the copper coin are placed in silver nitrate solution. When electrical current passing through the circuit, it can be seen that the silver strip is slowly getting thinner, whereas the copper coin is seen to be coated by a layer of shiny silvery solid.
Okay, here. So remember, in the SPM, normally you will see, if the electroplating question coming out, you'll be using the spoon or coin or key. These are the common or famous things that you need to electroplate. Okay, so based on the video here, now we can proceed to the suggested answer. Okay, so here I give you the roughly what you can see here. Okay, so the metal we can use here. Okay, we can use silver. Okay, silver to electroplate the spoon, not the coin here. Okay, so apparatus and the materials we need to use. Okay, we need the beaker, connecting wire, okay, battery, switch, then silver, okay, then iron spoon, so do not use the copper coin, okay. So silver nitrate solution, silver nitrate solution, or any suitable silver salt solutions, or silver so normally is silver nitrate. Do not use, reject silver chloride. Silver chloride is an insoluble salt. No? Okay. Next procedure. Okay. First, pour 100 cubic centimeter of copper 2 sulfate. So here we use the silver nitrate. Okay. Silver nitrate solution into the beaker. So copper 2 sulfate. If you want to electroplate the spoon with copper, okay, here we use the silver. So silver, we don't use the copper 2 sulfate, we use the silver nitrate. Okay, then connect the iron spoon to the positive, okay, must be positive of the battery, and the silver, we don't use the copper, silver at the negative terminal using the connecting wire. Okay, so dip the electrode into the solution, then turn on the switch. Okay. And this is how you can conduct the electroplating process. Okay, after that, observation, what you can observe here, the iron spoon at the negative terminal becomes thicker or coated with silvery gray solid. Okay. Next, the electrode at the positive terminal becomes thinner, or you mentioned the silver strip at the positive terminal. Okay, the half equation at the anode, silver be ionized to form the silver ions by release 1 electrons, undergoes oxidation. Then at the cathode, the silver ions will gain the electrons to form the silver solid, silver metal. So it will be coated on the copper coin here, or copper, electroplate on the iron spoon there. Now last question, question 10. Diagram 10 shows the flowchart for the reaction undergone by the compound X. Compound X is here. Compound X has less than 4 carbon atoms. Okay, so here we can look into the flowchart. Okay, I provide you a simple flowchart that includes all the homologous series here, so we can do the comparison here. So here undergoes process Y, produces C, C go back to positive chips here. Okay, so we can have a look here. Okay, X should be alkene, because alkene it will change to alcohol using the go through the hydration, and dehydration change back to alkene. Okay, so this is compound X. So you can choose whether the compound X can be ethene or propene. Okay, so later on I will choose the propene. You also can choose as ethene. Okay, so here process Y, as we mentioned, refer here will be hydration. Okay, so this one will be dehydration. So it forms, let's say here I choose this is a propanol, propene. So it forms a propanol. So propanol undergoes the acidified potassium manganese 7, which is the oxidation. So it forms a compound B, is called propanoic acid. Okay, then here react with the butanoic acid, so it forms a compound D. D is the ester. Okay, so our propene can undergo combustion. Propanol also can undergo combustion. Okay, now we look into the question. Suggest and identify the compound X. State the name for the Y. Identify gas A, compound B, C, and D. Okay, so just now I roughly go through already. So compound X I choose is propene. You can choose the ethene actually. So Y is hydration. A is carbon dioxide. Okay, gas A, carbon dioxide gas. B is propanoic acid. Okay. C is propanol. Okay. D is the propyl butanoate. Okay, is the ester. Propyl butanoate. Oh. So any question you can leave below the video here. Okay, B. Write the chemical equation for the combustion. X in an excess oxygen. Calculate the volume of gas A if released. If 0.25 mole of carbon X, compound X, was burned. Okay. So first we write the chemical equation first. So combustion of compound X. So just now we choose is propene, so C3H6. So combustion is react with oxygen, so it produces carbon dioxide and water, H2O. So we need to balance the equation. So carbon first, okay, 3 carbons. So here times 3. Secondly, we look into the hydrogen, 6 hydrogen here. So 2 hydrogen, so times 3, so 6. Okay. Next, we look into the oxygen. 3 times 2, 6 oxygen plus 3, so 9 oxygen. Here is 2, so we cannot get the odd number, so we have use the fraction 9/2. Oh, 9/2. So we get okay, we get the balanced chemical equations. Okay. So from here we can calculate, do the calculation. Okay, so 1 mole of propene produce 3 moles of carbon dioxide gas. Okay, so if 0.25 mole, so times 3, okay, cross multiply you to get 0.75 mole of carbon dioxide gas. So volume of gas, or mole times the molar volume, is 24. So you get 18 cubic decimeter. Huh? Okay. So you have to know here, if you choose the compound X is ethene, then your equation is different. Then your volume of gas collected also will be different. You can have a try here. So you can leave your answer in the comment below, then we can see whether your calculation is correct or not. Okay, C. Compound C react with the this one is the this one it should be butanoic acid to form the compound D, which is the ester. By using your answer in 9A, describe the formation of compound D. Your descriptions should include procedure, observation, and chemical equations. Okay, now I show you a video how to prepare the ester. Okay, so this is a propanol. You add 2 cubic centimeter of the butanoic acid into it. Then add few drops of concentrated sulfuric acid as a catalyst. Okay, then heat it, boil it after 15 minutes. So it will release a smell like a pear. Okay, like a pear. So which is the ester. So this is how we do the esterification. Okay, the simple one. Okay, so here procedure. Okay, here actually I include the simple diagrams. Okay, so that's still containing the reaction mixture. Okay, so ethanol, so just now is different, so this one is different one. Okay, so the combination of the alcohol and the carboxylic acid, okay, put into the beaker filled with the water. Then you heat it until it boils, and then it forms 2 layers of the mixture, and then you pour it into the water, and then it forms 2 layers of the liquid here, and then the top one will be the ester. It will be sweet smell or fruity smell. Okay, the procedure. Okay, add 5 cubic centimeter of the propanol into the boiling tube. Then add 5 cubic centimeter of butanoic acid into the boiling tube. Then add few drops of concentrated sulfuric acid into the boiling tube. Then heat the mixture, and then pour the mixture into the beaker filled with water. Okay, then record the observation. Okay, so you see it will produce the ester, which is the this one is another type of ester. This one should be methyl butanoate. Okay, methyl butanoate. So observation, fragrance smell or fruity smell is released, or sweet smell is released, and 2 layers of the liquid form when poured into the water, because the ester is insoluble in water. Okay, so chemical equation here. So is a propanol, okay, C3H7OH, react with the butanoic acid, C3H7COH. Okay, so we separate it, take out H and OH, then combine. So H and OH combine to form the water, then the remaining one becomes the ester. So this part comes from the propanol, this one comes from the butanoic acid. So this is the propyl butanoate, propyl butanoate. Okay, so that's all for this video. Okay, thanks for watching. You may share with your friends. So any question, any comments, you can leave under this video. Okay, thank you.